Another one. Use table method to evaluate the integral x to the power of 4 e to the power of negative x dx. That must be easy for you now, is that right? Our u will be x to the power of 4 and your dv will be e to the power of negative x dx. Let's construct a table. Well, below u, you write x to the power of 4. Below dv, you write e to the power of negative x dx. Well, I have been dropping that, but that should be there. Your dv is e to the power of negative x dx. Okay, now differentiate x to the power of 4 continuously until you reach 0. The derivative of x to the power of 4 is 4x to the power of 3. So 4x to the power of 3. The derivative of 4x to the power of 3 is 12x squared. The derivative of 12x squared is 24x. And the derivative of 24x is 24. And finally, the derivative of 24 is 0. We have reached 0 and we stop there. We now go to the right side and integrate e to the power of negative x dx continuously. What is the integral of e to the power of negative x? It is e to the power of negative x divided by negative 1. So it is negative e to the power of negative x. So integral of e to the power of negative x dx is e to the power of negative x times negative 1. So that is negative e to the power of negative x. Okay, what do you get if you integrate this? Negative e to the power of negative x. Now remember, integrating will produce a negative, and that negative and this negative will make it positive. So integral of this will give you positive e to the power of negative x. And integrating this will give you negative e to the power of negative x. And integrating that will give you positive e to the power of negative x. So how beautifully it rolls over. And finally, integral e to the power of negative x is negative e to the power of negative x. We have now done the integration and the differentiation. We can start picking our terms after assigning the signs. So assign alternating signs: positive x to the power of 4, negative 4x cubed, positive 12x squared, negative 24x, positive 24, and so on. And what is our first term of this integration? You pick our result like this: x to the power of 4 times negative e to the power of negative x. So multiply values below u with values below dv like this: x to the power of 4 times negative e to the power of negative x. That gives you negative x to the power of 4 e to the power of negative x. That's our first term. What's the next term? It'll be negative 4x cubed times positive e to the power of negative x. That would be minus 4x cubed e to the power of negative x. What's the third term? Will be 12x squared times negative e to the power of negative x. So that will make the expression negative. That would be minus 12x squared e to the power of negative x. Minus 12x squared e to the power of negative x. Our next one, 24 is negative and this is positive. So it will be minus 24x times e to the power of negative x. And finally, plus 24 times negative e to the power of negative x will be negative 24 e to the power of negative x. All right. What can you pull out from these terms? a negative e to the, you can see all these terms are negative. So a negative e to the power of negative x can be taken out, leaving x to the power of 4 plus 4x cubed plus 12x squared plus 24x plus 24 plus c as our result. Isn't this a beautiful way to integrate quantities like this? Yes. Okay, let's move on. Well, you can see only certain forms can be integrated like this, so you cannot depend on it for all integration by parts methods. Alright, now I want you to try this on your own using the table method. Integral x over e to the power of x dx. Use the table method to do this on your own and let me know if you have any problem. The answer should be this: negative x plus 1 over e to the power of x plus c. Okay? Alright, let's look at more of integration by parts. Find the integral, integrate x cubed ln x dx. Now, your tendency immediately will be to go and look and say x cubed, yes, I can integrate it continuously to get 0. Well, you'll be in trouble in this particular case and in many other cases. Why? Because if you take x cubed as your u, then you will take ln x dx as the dv. But a quantity that you choose as dv must be a form that you can integrate. Now, do you know how to integrate ln x dx? What is integral of ln x dx? I don't know, and I'm sure you don't know. So obviously, you cannot leave ln x dx as dv simply because you cannot integrate it. And so, in this case, we need to change. How do we identify our u and v? Because ln x cannot be easily integrated, it cannot be your dv. And therefore, you need to choose ln x as your u. If it cannot be your dv, then it has to be your u, is that right? So we choose u equal to ln x. If u equal to ln x, what is du? What is the derivative of ln x? The derivative of ln x with respect to x is 1 over x. And therefore, what is the differential of ln x? It is 1 over x dx. So, u equal to ln x, du is 1 over x dx. Well, if ln x is u, then your dv will be x cubed dx. Is that right? So your dv is x cubed dx. Alright, in that case, what is your v? V is obtained by integrating this. What do you get if you integrate x cubed dx? What is integral x cubed dx? Power rule will be x to the power of 4 over 4. So v will be x to the power of 4 over 4. So we have u, we have du, we have dv, we have v. What is the form of the integral? Integral u dv is u times v minus integral v du. So u times v, u is ln x, v is x to the power of 4 over 4. So u times v will be ln x times x to the power over 4. Is that right? That's your ln x is your u, x cubed dx is your dv. So u times v, u is ln x, v is x to the power of 4 over 4. uv minus integral v du. v is x to the power of 4 over 4 and du is 1 over x dx. Well, now simplify this. X cubed, x to the power of 4 over x will be x cubed, and this 1/4 can be taken out. Is that right? So identify them one more time. That's your U, that's your V, that's your du, and of course that's your V. So this will be, I'm going to write it as x to the power of 4 ln x, is it alright? X to the power of 4 ln x divided by 4, that is this term, minus this 1/4 comes out, 1/4 times integral x cubed dx, and this can be now done very easily. So that will be x to the power of 4 ln x over 4 minus 1/4 times integral x cubed dx is x to the power of 4 over 4 plus c. And now can we simplify this? Yes, x to the power of 4 over 4 can be factored out, or x to the power of 4 over 16. This term has 16 on the denominator, so we will factor out x to the power of 4 over 16. Remember, then the denominator and numerator of this will get multiplied by 4. So when x to the power of 4 over 16 is factored out from here, what is left here will be 4 ln x. So x to the power of 4 over 16 factored out, leaving a 4 ln x minus 1 plus c. And that's the result of our integration. Can you write 4 ln x in a different form? What is 4 ln x? 4 ln x is the same as ln x to the power of 4. If you want, you can also write it like that. Alright, another one.